Okay, just started recording the meeting. So we still have two videos for programming that need to be uploaded, and we will upload those in due time, hopefully on Monday, plus the other video on this one makes them full. Okay, introduction to SQL. So just a review there, the SQL's impact on relational databases. So SQL is considered the major factor in commercial success. Please go ahead.
Can you repeat? So when you asked me if my son made it, it wasn't hearing anything.
Okay. Okay. Is everything clear now? I can't see your thumbs up. Is everything clear?
Yes.
All right. So we just look at
Yes.
yes. Thank you for your response. We just look at the database from the theory point of view. Of course, we will spend much of time looking at the database from practical point of view. When we get back to campus, I think it will be even more convenient because you guys will be seated here and I will be seated here, and we'll start going through this database in a more practical way, and that is how you answer. With Dr. Zipani, I'm sure he did even tell you. Uh, I can assume. I can assume. Um, let me just confirm. Did he tell you that he's a practical man when it comes to database? Did he tell you? Oh no.
May I hear it from you?
Oh, you heard it from me. Sally, I mean Lissy, did he tell you that he's a practical man?
I don't know about that. I just
Oh, okay. So please take my words very seriously. And once we look at this, then we'll be able to send you. Maybe at the end of this, we'll be able to send you a question. Have it analyzed. Please do not use AI. Do not use AI. Try to be sincere. If you don't understand, you better ask, and we'll send you a scenario question. I hope I can still find that scenario question. I think on Google Class. I will check the one we had. So the review there, SQL's impact. So the impact of SQL on a relational database. We looked at what a relation is. Okay. So SQL is considered a major factor in commercial success of relational database because it becomes a standard language for these databases. Okay. Here it's SQL, not MySQL. MySQL is a type of SQL. So there's MySQL, there's a SQLite, there's H2, um, there's PostgreSQL, um, there are MongoDB, and all these. Okay, so we are just saying SQL is considered a major factor in any successive commercial business. You need a way of keeping the information. So this standardization, again, not a standard. Okay, it's a standardization. It's a reference, not the gold standard. It's a reference. So this standardization reduced the cost and effort of migrating applications between different relational DBMS products. This point is a different, is the advantage of the database. What are the benefits of a database? Number one is reduced cost. Okay? How is this a plus? If you are buying papers, every week you have 10 reams. You just have this software and cut on that cost. Again, it is efficient in terms of efforts because you don't have to be moving between offices. You can have the same software called the SQL, and in this SQL you have the tables. You just have a single database or two databases, then you have the tables differently. Okay, so it reduces efforts and costs. Okay, so relational DBMS and SQL standardization. While differences exist among various commercial relational DBMS packages, adhering or sticking to, adhering means sticking. Sticking to a standard SQL feature helps in minimizing compatibility issues. Again, this is a plus, which is your advantage. Okay, so how exactly is this a standard? I mean a plus. We are saying sticking to standard, okay, to the standard of this SQL helps minimize compatibility issues. So once you just stick to standards, those issues of compatibility are minimized. That's quite important. So users can write a database application programs that can access data across different relational DBMS without changing the database sublanguage, provided ODBMS supports the standard SQL. This is another advantage. So how is it an advantage? Okay, what are the advantages of SQL? You have them there. Okay, even when they ask my SQL, it's a type of SQL. So you say the cost and effort is reduced. Okay, number two, compatibility issues are avoided. Okay, number three, you don't have to be moving from computer science. Imagine you are printing your results, and those results, let's for example at first year, you have biology, you have chemistry, you have physics, you have biology, you have chemistry, you have physics, you have math, and these other courses. For example, you have different departments. So when you need your results, you have to go through each of those. Now, you have the database code. You have this application called Student Information System application, which is a web app, of course. Now, this Student Information System application has a database which stores your information. Okay, which is stored, of course, either on Amazon Web Services, on the cloud, or within the University of Zambia, for example, locally. So instead of you going, instead of users can write database application programs that can access data across different relational DBMSs without changing database sublanguages. Okay, so what we are just saying is data can be accessed across different relations. Remember, a relation is a table. Okay, so in that database of the student information system, there are tables. There is table for computer science, there is a table for that, there is a table for that. So in different tables, data can be accessed, okay, at a faster pace. That is an advantage. We are still on the overview. SQL and relational algebra, again, I keep saying the relational algebra, you learn about this in your third year when you begin learning about advanced database. I think the second semester. You are still finding Mr. Morphia. It's a very good man, and I like Mr. Morphia as well. So SQL and relational algebra. The relational algebra is just a mathematical way of looking at a relation. So SQL is a higher level declarative language compared to relational algebra. Relational algebra is just a mathematical way. Okay? You are looking at how. You are not looking at what. So SQL is a relational declarative language. High level declarative language. It means it is English-like. Okay? It is English-like. You are looking at what? That is what high level is. You are looking at what, not how. So, you ask someone, what is 1 plus 1? They will just say 2. Okay? That is what. But how? Then you are asking of exactly what happened for you to come up with this answer. That is how. And that's a relational algebra. Relational algebra is how. SQL is what. So relational algebra operations important for understanding the query processing. This relational algebra, they are just there to understand how those queries, if you say select or from, what is happening in the background, that is exactly how is the processing done. Okay, so it is just important for understanding query processing, optimization, and optimization that users require to specify how, okay, the operation should be executed. That is how part, relational algebra. SQL, on the other hand, allow users to specify what. Okay, you are interested in what, not in how. Okay, there's also history and evolution. Evolution means the stages that this went through up to what we have. That is evolution. If you remember your history very well, 10 monkeys, this monkey started moving not until it became a human being and the like. And I don't like this nonsense of saying, no, Africans came from a monkey. No. It's just the weather. That's why you can see Indians. They move from India where they have eyes very white. They come in Zambia because we do have a lot of sun. They start getting dark. So the sun, the skin adapt to that and produce a lot of melanin as the result of dark skin. Okay, that's not the topic of discussion though. So the history, okay, the SQL originated from the IBM. Of course, they will never ask you that, and was called SQL, which is Structured English Query Language. Okay, S is structured, E English, QUE query, L language. Then updates, okay, which is evolution now. This was history. Updates expanded the language, includes features such as XML. Okay, I think we no longer use XML. Yeah, we no longer use XML. I think we have HTML now. So XML and other database functionality. Still on the overview, SQL is comprehensive data language. Comprehensive means it has data definition language, like those create, select, and the like. Those are data definition. And data manipulation, such as update, delete, and so on and so forth. Okay, comprehensive. It brings together the data definition language and data manipulation language. So it allows defining the schemas. Schemas are description, creating and manipulating views, specifying constraints. Constraints are rules. For example, integrity constraints, I think we looked at that. Referential constraints, we looked at that. Video will come on Monday. Security and authorization, okay, and transaction control. Then SQL is also used for embedding in general purpose programming languages like Java. Okay, embedding means connecting. So you can connect SQL to Java, C, C++, C#, and so on and so forth. Okay, the core and the extensions. Later, okay, in as about 1999, going forward, we have divided SQL into core, specification, and specialized extensions. Okay, so a core is a standard, and this standard is required to be implemented by all SQL compliant vendors. Okay, this is a must. You have to stick to standard. For example, accepting the license and so on. Extensions are optional and can be implemented for specific applications such as data mining. Okay, OLAP. Okay, spatial data and multimedia data. I think for those of you that are going to go into software, data mining is one of important concepts that we should look at. Okay, so we will look at the SQL, that is data definition language, for creating table creation, how to define basic constraints such as key, for example, primary key, foreign key, unique key, default, and referential integrity. We will look at the basic structures for retrieval query, such as select. We also do the manipulation commands, such as insert, for example, insert into, for example, delete, update data. I'm sure we looked at the concept of inserting and deleting, but don't worry, we will still get back to that. So that was the overview. Before we dive into what we have to do, okay, is everything clear? Give me a thumbs up. Is everything clear? Oh no, and you're just alone in the meeting. Right. Okay. Okay, so on data definition language and data type, what we are saying, SQL uses terms, okay, such as table, rows, columns to refer to relational models, relation, tuple, and attribute respectively. So relation, table, tuple, row, column, attribute. So these terms are used interchangeably in discussions. So we looked at the main SQL command for data definition is create statement. Create. Okay, because the database you have to say create. The table you have to say create. So the main SQL command for data definition is create. Okay, so this is used to create the schema, the table, the type, and the domain. Other constraints such as view, insert, and triggers, there are other those, but the main one is create. Okay. Just give me a minute. Okay. Just give me a minute. Hey, you went out. Why? Are you experiencing? Okay. That's bad. So, of course, we haven't gone far, but what we are saying is, we These are the concepts. Were we together on the concepts that we have to go through in this chapter?
Why ended up
Where did you go out?
when you were talking about the relation of algebra?
I see. So okay, so we are going to look at these four concepts in this topic. So data definition language, okay, that's what we are going to go through. Then how to define basic constraints. Constraints are rules. And what are those rules? They are keys. For example, the primary key, the foreign key, um, the primary key, the foreign key, the unique key, and so on and so forth, and the referential integrity. So those are basic constraints. Okay, so we'll also look at the basic SQL constructs for retrieve or queries. We'll look at those in just a minute. We'll also try to look at the manipulation commands such as insert, delete, update, and so on. Okay, then here the SQL uses terms. Okay, please get used to these terms such as tables, rows, and columns. So these is just the English. Now the table is referred to as a relation. So wherever we talk about a relation, we talk about a table. A row is called a tuple. Okay, row, tuple. Column, attribute. Okay, so these terms are just used interchangeably in discussion. So the main point here is the main SQL command for data definition is the create statement. That's the main. Why? Why is the main? Why is creating the create statement is the main? It is used to create a schema, the tables, which are relations, the types. Of course, we'll look at what types are there, which is just basically the data types, and the domain. I hope up to this point you are in the meeting.
Yes.
Okay, good. Yes. Okay. So, is there a table that we can? Okay, maybe we don't have to go this further. Okay, just give me a minute. So data definition and types. Okay, so we have the schema, which is a description, and the catalog concepts. So SQL has a schema to group tables. Okay, has a description to group tables and other database constructs. So in a schema, which is in a description, so a schema has a name and authorization identifier for the owner. So that description, database description. So when you open my SQL Workbench, for example, okay, it has the name and authorization. Okay, so for example, it will ask you to enter your password, which you entered, and so on. That is for the owner. Then the schema elements, in that description we have the tables, types, which is the data types, which we looked at, but don't worry, we'll keep mentioning. Constraints, which are rules. The views, we'll look at the views at a later time, and more. So how do you create a schema? For example, you want to create a database called company. Okay, so you create then the schema name. Okay, create, okay, then the schema name. Okay, then you say authorization. Who is going to be authorized? Then the owner has to be authorized. You can put Sally here, you can put Erica here, you can put Cass here in that code. So create a schema, then the name of your schema, so in this case it's a company, then authorization, and so on. Okay, so what is the importance of authorization? It just makes sure that only administrators have an access to database. That's what it makes sure. Not anyone that comes has to have the privilege. No. So the system, you must find a way of making sure that the system has some level of consistency. So even when a certain aspect goes off, okay, you'll be able to say, you've been in charge, you are in charge. Explain what is happening. Not a situation where anyone, almost anyone or everyone is able to access that. Otherwise, your system is gonna be failing. Okay, so now you have a schema. You've created a schema. So you can create a schema number 1, a schema number 2, a schema number 3, a schema number 4. The collections of schemas is called a catalog. Sure, they have put it there. Okay, it's even here. Okay, so a catalog is a collection of schemas. That's very, very, very important. So each catalog includes the information schema, which provides the metadata. I wish I was offering I was offering this this practical way of looking at programming, so that you build yourself an application, which we started at some point, but I do have a lot. I think at some point before we close, um, maybe even for a few weeks or a month, we can resume that. I have been working tirelessly on my final year project around here, trying to perfect it, so it eats up a lot of time. So we can understand what metadata is. Okay, metadata is basically the engine behind. So there is this information which is controlling what we are unable to see. But we just know that when you say 1 plus 1, then you say equals, answer is 2. So there is this information behind which is processing, not visible to you as a user. this information behind not visible to you, which is responsible for how the page is running. That is what we are calling metadata. That's why it is called data about data. Yeah. So integrity constraints, we do have a lot of them. For example, keys and referential integrity. We are saying integrity constraints can only be enforced between schemas within the same catalog. And elements like types can be shared across schema in the same catalog. Remember, a catalog is the collection of schemas. So I'm sure you oh, please pardon me. I'm sure you've gone to ShopRite before, because that's where we like going. We rarely go to supermarkets like Choppies. Um, of course we do, but not as often as we visit ShopRite. So there are those papers with the colored products alongside the description and the price. They can say, okay, when you get this on a lay-by, you can pay in this month and the like. That is also a catalog. Okay, it's more like a newspaper with a painted picture, but we're just using that as a reference, though. So what we are saying is that catalog can only be shared among the ShopRite. So in the same way, integrity constraints can only be enforced between the same or between schemas in the same catalog. Okay. So use the create table or relation in SQL. So create table. We of course we looked at this from the practical perspective, but don't worry, we'll still look at them from practical perspective as we do all this. Okay. So we are still on the data definition. So how do we create the table? So we just use a command create, then the table. Then you give the table name. Okay. The table name is so each attribute is defined with a name, a data type, which is a domain, and optional constraints like not now. So key constraints like the primary key, foreign key, not now key, unique key, and so on and so forth. Entity integrity, referential integrity can be included in create table. All these we are of course we are going to look at these. Please, for now, understand these. We'll look at them properly from practical point of view. So when we say create table, then in this table we put columns. Then we can say this column is a primary key. This column is the unique key. This column will have the auto increment feature, and so on. We will there. Okay, so create table. You can create views using create view command. Okay, a view. Okay. So a table is physical, a view is logical. Okay. So it's like you. There's a person, a real person standing here. Now there's a mirror. So there is that reflection of you. So you are seeing another person via the mirror, but that person isn't the real person. The real person is the one outside. In the same way, a table is physical. A view is logical. Okay, so a table is stored, okay, explicitly. A view is not explicitly stored. Okay, so but these may not be physically stored. A view is not physically stored. Okay, a table or tables are physically stored. This is one difference. Please, please, please. I have seen questions around here. What are the differences between a table and a view? Okay, so there are a lot of differences here. So one of them, a table can be created by create the table command, while a view can be created by create view command. Okay, so a table is physical while a view is virtual. A table is physical while a view is virtual. A table can be physically stored in DBMS, while a view cannot be physically stored in DBMS. Are we together there? Erica, are we together? Okay, good. Okay, so this is how we do that. So create table, then the table name. Okay, and this is the best way of doing it. So create table, then the table name. And you have to always put a semicolon here. Okay. Then I also have seen a question, questions on secular reference. So a secular reference is just a foreign key that refer to the same table. So foreign key that refer to the same table. So this is a table, and this table contains a foreign key. But this foreign key, it leaves, instead of pointing to another, it points back to itself. That's a secular reference. Again, it doesn't have to be a foreign key. What is important is you say a key that refer to the same table. Okay, don't worry, we're gonna look at what an alter command is. Okay, so this is what we are doing. Though we didn't do this part, but we are moving slowly but sure. So we have create table, then the table name, then you put columns there. So the first name, Okay, is mid initial, last name, uh, and so on and so forth. So the first name will have the variable character of 15. So this specifies how many characters you're going to have for the first name. That's why we're saying variable. Mid initial, just cha, which is a character. Most times is just a single letter. Last name, same variable character. SSN, social security number, just a character there, and we want up to 9. Birth date, we will use date, and so on and so forth. So this is a column, this is a column. Columns are found in the table. Are we good here? Erica, are we good? Though my light here and I didn't charge my PC, my God. Okay, I will say when it starts running low. So create table name, you put in columns there. These are some of the things that we're gonna look at. We'll look at this from practical perspective. All those. Okay, I'm back. So we are still on data definition language. The attributes, we talked about attributes a lot of times. Just those characters which gives more information about entities. Then the data type the data types are things like that. My PC may go off, so I have to save the recording. Sure, we can end here for now. I will discuss once. Okay, it's very long. I hope we are fine up to this point. Are we fine up to this point before my piece go low? Do you have?
Yes, sir.
Okay. Do you have a question first? My PC may go off. Do you have a question?
No.
Okay.